So first is I call some geometry, okay, or I make some geometry.
Okay.
Let us make a geometry in the geometry modeler.
Yes.
New geometry. Now I am using ANSYS 15. So geometry modeler is same in ANSYS 15 or the latest version ANSYS 22. Okay, there is no difference. So uh, if you are using some another version, there is no problem in going to your geometry modeler. Okay, only
Yes, sir.
you don't go to space claim.
Yes.
There are two
Yes.
options: space claim and
Design one.
geometry modeler. Okay, so always use geometry modeler.
Yes.
Otherwise, space claim will take hell of a time.
Yes. Yes.
Now, first you set the unit. Unit is here. It is showing meter. I am. I should go in millimeter. Okay, because
Millimeter.
earlier one was in millimeter.
Yes.
Now let us make some geometry. First, you have to do a sketching. So I go to sketch. Now here it is showing XY plane. Okay, so sketch will be in the XY plane only.
Yes.
Now I am doing some rectangle. You see cursor. Okay, when you move the cursor on this axis, it is showing some symbol C. Okay,
Yes. Snap points.
and when I go to this your center point 0, 0, it is showing P.
Yeah.
So this is the geometry. Now go to dimension. It's a simple geometry. Okay,
Yes.
dimension. I go to
Horizon.
dimension. You see,
Okay.
select this and click here. It is going on dimension. The name of the dimension is H1. Again, give this dimension. It is V2. Now change the dimension H1. Say H1 is 200 millimeter. Okay,
Yeah.
and this is your of say 30.
40. 30.
It is I'm giving 30. Now the sketch is done. This is the only sketch. Okay.
Hmm.
Now give a jet command.
Hmm.
Generate. Here generate is there. Generate. Okay. So sketch has been generated.
Hmm.
Now go to
We have
model.
to go modeling.
Here go to modeling. So create
Extrude.
X2. Give some thickness. I give 6 millimeter.
Yeah.
There are some other type, extension type, extend type. So options are there. Here it is fixed. Okay.
Fixed means fixed cross section.
Fixed. Direct direction is normal to the your sketch plane. So direction is normal. Okay.
Okay.
Now giant. Again give the giant count. So you are done.
Hmm.
So this is done. Okay. This is 10 millimeter unit. Now go to project page.
Hmm.
Check unit. I have this millimeter. So this
Yes.
unit you will check before going to the design model. Okay.
Yes.
Now click on model. Model means I am going into the mechanical side of it. Okay.
Yes, sir. Okay.
Geometry has come.
Yes. Now we have to generate the mesh.
Just press the middle button and your drag it. Okay. So it will rotate.
Hmm.
Now you go to the geometry. Solid.
Hmm.
It is showing structural steel. So by default,
So,
it has taken structural
sir,
steel. I have not created
unit
any new material.
is required to be changed here. Unit.
I have not created any new material. Okay. So structural
Okay.
steel, it has taken as the default.
Okay.
Now it is showing a coordinate system. By default coordinate system, it is showing global coordinate system. It is here. 0,
Hmm.
0 is here. This is Y,
Hmm.
this is Z, and this is X.
Hmm.
Now mesh. I have to create mesh. So you go sequentially. Okay.
Yes,
Geometry,
sir.
then coordinate system. I need not to do any coordinate system here. then take the mesh, then you go here like that. Okay, so go
Yeah.
from top to bottom. Okay.
Top to bottom. Yes, sir. So what is the unit here? Unit.
So again, set unit over here. Unit. It is
Unit.
metric, millimeter, kg, Newton second. Everywhere, whenever you will change the workbench, you will
Yes.
set the unit, check the unit or set the unit. Okay.
Yes,
All
sir.
the units should be your same.
Same. Yes.
All the unit in all design modular will be the same. Okay.
Yes.
Now here unit is showing degree. You can go to radian also, RPM, radian per second, RPM. Temperature is this, like that. So as per your requirement, you set the other options. Okay. Okay.
Okay. Okay, sir.
Now you see, yeah, tick mark is there. That means geometry is okay, solid is okay. We have defined the material, so it is tick. Now here coordinate system is okay. Here some question mark. Here some yellow mark is there. That means some input is required here. Some action is required here. Okay.
Yes, sir.
And on question mark is there. That means some input is required. Question mark is there. That means some input is required. Okay.
Yes.
Now mesh. So mesh, it is asking to do the mesh. I am not doing the mesh now.
Okay.
I will do the mesh.
Okay.
Mesh. Mesh type. Mechanical is there, and other options are electromagnetic and
Save.
explicit. Okay.
Yes.
So these are the four options. So we are interested in mechanical.
Mechanical.
So click mechanical. Yes. You go to sizing.
Sizing.
Advanced size is off. Okay.
Hmm.
One is relevance. Relevance, you click here. So slider is there. From here, you go to this side, left side. It is your rough mesh it is creating. If you go this side, it is fine mesh it will be creating. Okay.
Okay. Okay, sir.
Now keep it as it is where it was. 0. Advanced size off. Now I am not going into the very details of it. This will come after when we do the mesh. Okay.
Hmm.
Now it is coarse.
Hmm.
Here you can go medium or fine. Okay.
Hmm.
Medium means it will create more elements and nodes. Fine means it will create further more elements
Okay.
and nodes. Okay.
Hmm.
So we are going to medium because our model is not that much critical. So we are going into the medium mesh.
Hmm.
Right click giant mesh. So it has created the mesh. Okay.
Hmm.
Now if you are not you're fully satisfied with the mesh, then go to right click on the again mesh again and clear generated data.
Clear generated data. Okay. Okay, sir.
Okay. Again I am going to the mesh. If I go to fine, now let us see what it will do. Update mesh or giant mesh. Okay.
Sure.
So it is. Now how many nodes and elements it has created? Let us check. Statistics. So nodes 12,096, element this much. Okay.
Hmm.
So many nodes and elements it has created. You can check
Okay.
over here. Changing to medium, otherwise it will unnecessary. It will take time. Okay.
Hmm.
Update mesh. Now we will give acceleration load on it. First,
Hmm.
restrain the model. Okay.
Yes.
Go to static structural. So this is stick now. Okay.
Hmm. So mesh has been generated. Now we have to
Insert
load.
insert the fixed support.
Okay.
We have to give some support first. So select this. Here you see selection filters are there. Okay.
Hmm.
This is
So
the
we have to select surface.
this is line. This is surface, and the
Yes.
volume is your gray out over here. It's not required now. So
Hmm.
surface is highlighted. So you select the surface.
Yeah.
This one with control pressed. Go to other side of it.
Okay. So selecting more than one, we need to press
Control. Press the
control.
control. Multi select for multi select. Apply.
Multi selection. Yes, sir.
Okay.
Hmm.
Now this tick mark. Okay. That means fixed support is given.
Hmm.
Now we have to give load. Insert acceleration. First one is
Excellent.
acceleration. So what is
Okay.
acceleration?
Acceleration means rate of change of velocity
Yeah,
with respect to time.
yeah. Acceleration can be defined by component or vector.
Vector.
So I
Yeah.
go to acceleration near the goal. Now here it is vector or component. Okay,
Hmm.
these options are there. Body will move in the opposite direction of the applied acceleration.
Hmm.
So that direction along which we give the acceleration, body will
Hmm.
move in the opposite direction.
Yes.
If we apply
Yes.
load, the body will move in the direction of the load. But in case of
Hmm.
acceleration, it will move or it will deflect in the opposite direction of the load. Okay. Now let us see.
Okay.
So we change the vector to component.
So, what is a vector and what is component means? Means x1.
Vector means it's a normal to
Okay.
the flat surface. Okay.
Okay.
Component means you give x, y, z directions. Okay.
Okay. Okay.
Now we select z direction.
Hmm.
Z direction. Give some acceleration. So we give any acceleration 10. Okay.
Yes,
Per
sir.
second square. Or give some more 50. So you have given a graph, it is showing from 0 to this, okay? And it's a
Yeah.
tabular data, it is showing. At 0, it is
Yeah.
0. At your second step or time 1, it is 50.
50.
Okay.
Okay.
So I have given in the y direction. It's not y, it should be z direction. So I
Yes.
give 50 over here, okay? And
Hmm.
this is 0. So arrow is showing in this direction. It will be uh,
Plus set.
minus 50.
Okay.
I will give in the reverse direction, okay? Minus 50. So arrow has been reversed.
Okay.
Okay?
Hmm.
I'm giving in this direction. So you can give minus value also.
Hmm.
Now solve. Now you see, take out some result. Insert deformation, I give total. Okay. So many
Hmm.
options are there. I am
Hmm.
for this year, I am taking deflection also only.
Hmm.
Now right click, evaluate all result. You see, so acceleration we applied in this direction, it has moved in the opposite direction.
Hmm.
Is it okay?
Because of the reactions. Yeah.
Right.
Yeah.
Because of the reaction. So, so it has moved in the opposite direction. This much it
Hmm.
is clear.
Hmm. Yes. Sure. Uh. Okay. Okay. So, one thing is there why we are considering the acceleration, because basically the we can uh, means we can give the force value. What why we are giving here the acceleration value?
Now, when let us take the example of a vehicle, car.
Okay.
When it is moving,
Hmm.
oh, if we press the accelerator, all on a suddenly it will change the velocity.
Hmm.
So, so your inside component, there will be whatever it is, there will be a little jerk.
Hmm. Hmm.
So instantaneous stage will come.
Okay.
That's why the acceleration. Okay.
Okay.
So this is this. Now I delete the acceleration load. Delete. On the same model, I give gravity load.
Gravity load. Whenever I mean, like 1G, 2G,
Yeah, yeah.
right? Yeah.
Standard Earth gravity.
Hmm.
Value applied coincides with the selected unit system. That means whatever the unit system, it will coincide with the unit system. It is
Yeah.
defined along one of the three global or local coordinate system. You can your gravity in X, Y, and Z direction. No? Okay, in any direction.
Hmm.
Body will move in the same direction of applied gravity.
Okay.
Clear?
Hmm.
Now, insert standard earth gravity. Second one is standard earth gravity. Okay,
Okay.
you select this one. Now, Z component. So it is
Yes.
saying minus
In
9803.6. We can't change
-980.
this value. Okay, this is
Hmm.
the only value. Okay,
Hmm.
this is the standard one.
Standard value. Yeah. 9.81
So Z
meter per
direction it
second.
is showing. I
Hmm.
can change. I cannot change it right now for here. Okay.
Okay. It is taking only at the
Direction is
minus
minus,
Z component.
minus Z. I can change the direction. I can give it.
Okay. Okay.
If I change it over here, so many directions are there. Okay.
Okay. Okay. Okay.
Minus or plus. So many directions are there. You can give any direction. But here you
Yeah.
cannot change. In the tabular data, you cannot change it.
Hmm. Hmm.
Okay.
Okay.
So you can solve it. Total deformation. So gravity. In this case, it has your deflected in the direction of the gravity, applied gravity.
But sir, why it is now showing in the opposite direction means two
It's not showing the opposite
gravity.
direction. It is showing in the direction of the applied load, applied gravity. In case of acceleration, it was in the opposite direction. In case of gravity, the direction is same,
Hmm.
the applied direction. Deflection is same in the applied direction.
Okay.
Hmm. Now, rotational velocity. I am coming this afterwards because example will be big. So I am going to pressure now.
Okay.
Okay. So I am not changing the model.
Hmm. So delete the gravity load.
Hmm.
Yeah.
So everything is same. I will be giving pressure in the negative z direction. Okay.
Okay, sir.
Hmm. Now insert pressure
Hmm.
magnitude.
Hmm.
Here now, but by default it is saying it is showing normal to
Yeah.
the geometry. Pressure I will apply on this face. So you see in the selection filter only your surface is available. Okay.
Hmm.
All other grayed out. So pressure you can give on surface only.
Surface only. Okay.
Select the surface, apply pressure. By
Hmm.
default, it is showing normal. We can, in this case, you can select normal to no problem,
Hmm.
and or you can give by component.
Okay.
By component, okay, or you can give some vector also. Okay,
Hmm.
no component. You give negative z minus z. I give say okay.
2 MPa.
Now solve it. Total deformation. You can give your stress value also.
Yeah.
Stress equivalent bond miss we see. Okay,
No, it is strain you have selected, sir.
or stress value. Delete. Okay. Now insert stress equivalent one miss. Evaluate all agent. So it is showing stress. So this your graph or the graph is showing
Hmm.
the stress values. Okay. So this
Hmm.
color it is depending on the color. When you go
Yeah.
going from top to bottom to top, the stress is
Hmm.
increasing. Red means
Yes.
stress is the at this zone stress is the highest. It does not mean
Maximum.
that it has crossed the your it will fail here or it has crossed the yield stress. That you
Okay.
have to check, okay, how much yield stress the material supports, know whether this yield stress is well or within the factor of safety of the design stress or not, okay.
Okay, okay, sir. So 970.88, that value it is indicated here, that is the maximum stress which is generated in the model. That's right, sir.
That color, the color
That
which
color.
is showing red, at
Hmm.
those locations, maximum stress has been generated. Okay.
Yeah. Okay,
The
sir.
maximum stress means it is not that it will fail. People are
Hmm.
not going to feel that stress means red means it will fail. It's not that.
Hmm.
Red
Yes.
means whatever stress it has
It is.
come, so the maximum generated stress is here. It can be
Yeah.
well within your design stress. Okay.
Yeah.
If it's
Hmm.
more than your design stress, then it will fail.
Okay. Okay. So
So
it,
it is a unit. It is showing your unit here. So
EMPA.
this is
Okay.
the okay. Now you can animate it. So this is a pressure. Pressure you can apply on the surface.
Hmm.
Now, if it is a cylindrical object,
Hmm.
if it is a cylindrical or spherical object, ठीक है? Then in
Hmm.
that case you have to give normal pressure. Not
Hmm.
in the case of,
Yes. Yes. Because it will act in the all direction.
it will act in the towards the center.
Hmm.
ठीक है? From the center it will act in the normal direction. So, okay, normal
Normal
direction.
direction. Normal to the boundary. Yes.
So
Yes.
in that case we will not select your vector. Okay,
Hmm.
vector or component.
Hmm.
Now go to hydrostatic pressure. I am coming. I'm showing the most common loads first. Okay, then we will go into the non-common loads. Okay.
Okay, sir.
So go to rotational velocity you have not shown.
Hmm.
Hydrostatic pressure will show afterwards. Now we are
Hmm.
going to your most easy forces. Okay, the
Hmm.
force.
Hmm.
Force is in Newton.
Hmm.
Force. So you have to apply the. We have to give the value. So question mark is there. Okay.
Yeah.
Now you see force you can apply on surface, edge, or any vertex. Okay.
Point. Point. Yes. Hmm.
Now force. First you go to magnitude. Here we give. First you have to select the geometry. Okay.
Yes.
So it is blue over here. That means it is asking to select the geometry first.
Hmm.
So you select the geometry. I select this edge. Go to the edge selection.